Hello, mathematicians. This is end of year math homework 15 and 19. So let's look at page 15 first. It says, for each problem, write an equation. So we know we have to write something with an equation. You can write these with one equation, but it seems maybe slightly advanced. So I think I'm going to separate it into two separate equations, and that's what I'm going to do. Okay. It says a museum has 42 dinosaur bones. 18 bones are on display. The rest of the bones are stored in 4 boxes. So I need to know what is the rest of the bones. So I'm going to start with 42, and I'm going to subtract 18, okay? And that will tell me how many we have left, or what the rest is. So my first equation, and I'm going to write a little bit small because I need to fit 2 in there, 42 minus 18. And some of you can probably do that in your head, but if you can't, you could always do a little bit of work off to the side to get an answer of 24. Okay, so that's the rest. Then it says that number, 24, are stored in 4 boxes. How many bones are in each box? So my second equation is going to be those 24 that are left divided between 4 boxes gives me a total answer of 6. And then I think I'll write 6 bones. Now, it uses the variable b. So if instead of writing 6, if you wrote equals b and then said what b equals, that's cool too. So if your equation is all combined into one equation, which is possible, totally fine. If you used a variable and then wrote your answer separately, that's fine too. But know that the official answer is 6. So we had to do 2 steps to get there. And if you look at the very tippy top of the page, it says that page 15 is solving multi-step problems. So it makes sense that there was more than 1 step to get there. All right, number 2. A store has a sale bin with 14 toy cars in it. There are 7 race cars and 2 Jeeps. The rest of the cars are vans. How many toy vans are in the bin? Okay, so the first part is 7 race cars plus 2 Jeeps equals 9 vehicles altogether. And I know that there are 14 total. The total number of race cars is 14. And if I take the total minus the 9 that are race cars and Jeeps, that will tell me what is left. And what is left would be the number of vans. And 14 minus 9 is 5. And I'm going to label it with the word vans. Again, if you combined this, and there is a way to do it, into one equation, that's cool. And if you use the variable v, that's cool too. And if you wrote that the answer is 5 off separately, that's fine. So if your answer doesn't look exactly like mine, that's okay. Number 3. The piggy bank has 21 quarters, 16 dimes, and 13 nickels. There are 3 times as many pennies as the rest of the coins combined. So let's combine the rest of the coins first. Let's take the quarters, the dimes, and the nickels, and let's see how many quarters, dimes, and nickels we have. And I know that we're going to have 3 times as many pennies, okay? So let's take 21, that's the number of quarters, plus the number of dimes, plus the number of nickels. And if you can't do it horizontally, which I much prefer adding vertically, I'm going to do that off to the side here. And I get a total of 50. Multi-step problems, I always have to read like at least twice. So let me read it again. 21 quarters, 16 dimes, 13 nickels. And then there are 3 times as many pennies as that. So now let's take that number 50. And I know that we have 3 times as many pennies. So let's multiply by 3. 5 times 3 is 15. 1 on the left. So we have 150 pennies. You could write it with one equation, kind of all combined. You could have used the variable p, but then p, of course, equals 150. 150 is our answer. Number 4, the bag has 68 pretzels, Ms. Mirabella eats 3 of them. Then she gives 3 pretzels to each of her 21 students. How many pretzels does she have left over? Gosh, I might even do this one in 3 steps. Let's see. So let's start at the beginning. 68 pretzels. I'm reading the question again. Ms. Mirabella eats 3 of them, so I need to take away 3, right? If somebody eats something, we have less now. 68 minus 3 is 65. Okay, then she has 21 students, and she gives 3 pretzels to each. Let's do that part of it. Let's take the 21 kids, and let's multiply. 21 times 3. 21 plus 21 plus 21. I know the answer is 63. I can do that in my head. If you didn't know that, you could always do it off to the side, right? 21 plus 21 plus 21, or 21 times 3. All right, so I have how many pretzels she has left over after she munches 3 of them, right? That number is here. And here's how many pretzels she wants to give to her students. And the question is, I'm reading it again because there's so many steps, how many pretzels does she have left over? So let me take 65, right? That's how many there were after she ate 3 of them. And if she gives 3 also to all of her students, what a fair teacher. That means she needs to give 63 away to her kids. And that leaves her with 2, which she will then share with her teacher, Mrs. Johnson. Okay, 2 pretzels left over. So this was a 3-step problem. Again, if you did it in a different order, or your equation! If your equation or equations look a little different, that's okay. All right, number 5 is a multiple choice, but we still might have to do a little bit of work. Number 5 says, the librarian bought 7 new bookshelves. He has 34 new nonfiction and 47 older nonfiction. If he places the same number of books on each shelf, how many books will he have on each shelf? So let's add the books together first. 34 new books plus the 47 old books. Okay? So I'm going to do the number of books added together. .34 plus 47, right? Okay, 81. And then it says we have to divide those 81 books amongst those 7 shelves. So I'm going to take 81 divided by 7. So we're going to do a long division problem. I know there's going to be a remainder because 81 is not a multiple of 7. I can tell there's going to be some left over. Okay, so I'm thinking groups of 7, groups of 7. How many 7s fit into 8? 1. Let's multiply. Oh, do you remember the whole thing? Divide, multiply, and subtract. Again. All right, let's multiply. 1 times 7 is 7. Subtract, bring down. How many times does 7 fit into 11? 1 time. Multiply. 1 times 7 is 7. Subtract. Nothing to bring down. That's when you know you're done. That's right. So we have 11 on each shelf, and then there's 4 left over. Okay, so which one shows that? Letter D. 11 on each shelf with 4 left over. Okay, let's look at the last one on page 15. Dr. Kim sees 8 patients per day on Monday through Friday. So that'd be 8 on Monday, 8 on Tuesday, 8 on Wednesday, 8 on Thursday, 8 on Friday, right? He also sees 4 patients on Saturday. If he's closed on Sunday, how many does he see per week? So 8 patients for those 5 days a week. Monday, Tuesday, Wednesday, Thursday, Friday. My daughter sings a song to learn the days of the week. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay, so for those 5 days, we have Monday, Tuesday, Wednesday, Thursday, and Friday. 8 times 5 is 40, plus an extra 4 patients on Saturday for a total of 44 patients. All right, let's take a look at the second side, page 19. And it talks about the factors of 4. Factors are those numbers we can multiply to get a certain product. So what numbers can we multiply to get 4? And maybe we could sing our song. Somewhere under the rainbow, factors fly. To get a product, they're the numbers that you multiply. That's right. All right, the factors of 4. I know we can do 1 times 4. And then you can also do 2 times 2. If you notice that there were only 3 blanks, it's because you don't have to write 2 twice. You can, but really writing it once is probably more mathematically accurate. If your numbers are in a different order, that's cool too. If you wrote 1 times 4 and 2 times 2, that's cool too. Okay? Now the multiples of 4, let's do some skip counting. Okay, I always start at 4. I've never really seen it starting at 0, but still, let's skip count and count by 4s. So we have 4. What comes next? 8. Next, 12, 16, 20, 24, 28. So I can think 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, 4 times 6 is 24, 4 times 7 is 28, and so on and so on and so on. All right, factors of 6. What can we multiply together to get 6? We can do 1 times 6 and 2 times 3. If yours are not in the same order, that's okay. And if you put a little multiplication sign between them, that's okay too. Multiples of 6, so I'm thinking skip counting by 6, or I could think 6 times 1, then 6 times 2, then 6 times 3. All right, if you know them, shout them out. We have 6, then comes 12, 18, 24, 30, 36, 42, and of course we could go on and on and on and on and on. 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30, 6 times 6 is 36, 6 times 7 is 42, 6 times 100 is 600, so 600 would be a multiple of 6. All right, factors of 2, we can multiply 1 times 2 to get 2. And multiples of 2, these are always super easy. Multiples of 2, ready? 2. And so on and so on and so on and so on and so on. Of course, factors of 5, what can we multiply together to get 5? 1 times 5, right? Which makes 2 a prime number and 5 a prime number. Do you remember that? Right? Numbers that only have 2 factors, 1 and itself, are totally prime numbers. Right, so 5 is a prima donna prime as well. Multiples of 5, super easy. Ready? 5. And so on and so on and so on and so on and so on. That's right. And finally, factors of 9. 9 is not a prime number. 9 is a composite number because there are more than 2 factors. You can do 1 times 9 and 3 times 3. And you only have to write 3 once, which is why there's just 3 blanks. If you wrote it twice, though, that's okay too. Multiples of 9. Counting by 9s. Who's up for it? Ready? 9. Think 9 times 2 is 18. 9 times 3. 9 times 4. 9 times 5. 9 times 6. 63, so on and so on and so on. Okay? All right, kiddos, let me just flash the answers here for page 15 and page 19. Tell how you can skip count to find multiples. Don't worry about that little star at the bottom. All right, my dears, I'll see you in class.